delighted to be joined here today by Markus Anderljung, whose work aims to identify new and improve upon existing AI governance policy recommendations. And he conducts research that focuses on the potential global diffusion of the EU AI policy, surveys of AI researchers, compute governance, and responsible research norms in AI. He was recently seconded to the UK Cabinet Office as a senior policy specialist, where he advised the UK government's approach to AI regulation. He was previously the deputy director for the Center of Governance of AI. He was the executive director for Effective Altruism Sweden and a senior consultant at Ernst & Young in Sweden. And we're delighted to have him here today to talk about filling gaps in trustworthy development of AI. So thank you so much, Markus, for joining us. Even though you're just a little bit north in San Francisco, we're delighted that you're here. And please take it away.
Thank you so much. Yeah, really excited to be here and excited to, hopefully say some things that are helpful to you all and that maybe you could learn from. And ideally, I would also get a chance to learn from you all as well, maybe primarily during the Q&A. I'll just first give you a little screen share. Yeah. Can you all see that?
That looks perfect, yeah.
Nice. And I hope you cannot see my speaker notes. Is that right?
Yes.
Great.
We see that, yeah. Oh, actually, looks like the window might be clipped on the right side.
Oh.
Oh, there we go. Much better.
We're gonna have to do. Does that work?
Now we see your Chrome browser, but it's better than before.
Okay. Let's go ahead and do that.
Yes, that's quite good.
Great. Okay. Yeah. So so I am very excited to see you all here. So the paper that we're talking about, toward trustworthy AI, it basically tries to answer this question of sort of as AI capabilities increase, as we start using AI in sort of a larger part of society in more high stakes domains, how can we ensure that sort of AI is developed and deployed in a trustworthy manner? What are sort of tools that we can develop that might sort of help us meet that goal? So the paper aims to answer these questions. The paper that you were linked to was this sort of actually this write-up of a much bigger paper with a lot more detail that you might be able to dig into, that you can see here on the left, which is a really big project involving 51 authors. And it was driven primarily by a lot of people that weren't me. So I want to give kudos to the people who did most of the work on that kind of stuff, which was Miles Brundage, Shahar, Jasmine Wang, Haydn Belfield, and Gretchen Krueger. And then this paper was then summarized in this science paper that you were all linked to. I'll try to sort of keep a fairly high pace in talking things through. But if I do run over, then please go ahead and stop me. So basically what I hope to do during the talk is to first sort of talk about why we might need what we call in the paper sort of mechanisms supporting verifiable claims. What are sort of the reasons that we need this, and sort of what are sort of the mechanisms that sort of drive that need? Then we'll sort of talk about sort of some difficulties in ensuring that you manage to verify and communicate certain claims about your systems, and then we will go through some potential mechanisms, just highlight some particular ones that I think might be relevant to you all. So this is sort of at least a causal model as I think of it in this domain. So the thought is something like, one way to give context is there's a lot of work in AI and machine learning where we are trying to figure out how can we make sure that our AI systems have certain desirable features. So this list of desirable features, it will include things like robustness, accuracy, fairness, and these kinds of things. But in addition to that, we argue there's this other really important process that needs to happen, which is not just figuring out how to make a system have a certain feature. It's also being able to verify whether it has that feature and being able to then communicate to other actors in the sort of wider AI ecosystem the sort of that claim to them in a way so that they can trust that claim. So we first need to be able to take the step of being able to test and verify claims about AI systems. So figuring out whether they're fair, whether they might be able to cause a certain kind of harm, those kinds of things. In addition to that, we need to be able to communicate that claim to others, be that sort of other AI developers, be that governments, journalists, users, the public. And the claim, in my mind, the sort of main claim of this paper is that we need to do that. And because that's going to be absolutely crucial to be able to build a trustworthy AI ecosystem. And the mechanism here is if you don't manage to do that, then it's going to be very, very difficult for other actors in the ecosystem, be it users, customers, government, whatever it might be, for them to be able to provide like appropriate sanctions and rewards for developers taking appropriate steps or acting responsibly. And that sort of step of the process, that sort of sanctioning and rewarding, could happen via a whole bunch of different things. It could happen via regulation. It could happen via employee activism, consumer behavior, a whole bunch of different mechanisms. But I think the thing that's really, really crucial is we can't get this process going unless we have some way of accurately sort of giving those outside actors, giving them an accurate view of how trustworthy different developers and different AI systems are. I guess another way to sort of put that is in some way we want sort of society as a whole to create a sort of reward function for AI companies or for AI developers or for those who sort of deploy AI systems in the world that might have a significant impact. And in order to be able to create that reward function, one of the crucial steps is to figure out who is being responsible, what system has features that we should be praising or sort of attacking or whatever it may be. So that's what we sort of focus on in this paper. We focus on these sort of first sort of two steps of this process. So trying to figure out how we can verify claims about AI systems and their impact, and be able to then communicate those claims to other actors. However, getting this kind of thing done can be pretty tricky. If we start with sort of being able to verify claims about AI systems and their impact, there's all of the issues that you will be aware of things like sort of the algorithms being fairly opaque, both in terms of, I guess, how they will behave, but perhaps more importantly, how they will end up having an impact on the world, because sort of understanding what impact they will have on the world, whether they might sort of lead to a biased or unfair outcome, for example, that's something that you cannot figure out by just looking at the system. You're going to have to look at this sort of wider socio-technical context that will determine whether your system is going to have a negative impact in the world. And so this can be a very, very challenging thing to do. There's lots of work to be done by you all and our whole community. On top of that, there's sort of this other difficulty, which I think is really important to be aware of, which is this difficulty of then actually communicating your claims about your system. And so currently there is an AI developer, they might say all kinds of things about the quality of their system, but if others cannot trust their claims, or others cannot know that they are accurate, or whatever it might be, then you're going to have some issues, or that's going to make it very difficult to get this sort of right reward function going. We have some ways in which this ends up being a problem. One is that sort of currently we have a bit of a sort of prevalent lack of trust in a lot of AI developers, I guess in particular sort of big tech companies. I'm a little bit less aware of sort of how you would imagine the sort of level of trust in the healthcare domain is, but I would imagine that there would be a reasonable amount of sort of skepticism around about sort of the veracity of various claims that companies are making about how useful their systems are or whatnot. And in addition to this, and I think maybe the sort of more important thing is that we often have these what you might call privacy trade-offs. So a company, one solution that a developer might have to the problem of people not trusting what they're saying is that they just sort of try to sort of communicate more They might, initially they might say, oh no, our system has feature X. People say, oh no, we don't actually trust what you're saying there. One way that they could try to solve that problem is that they increase openness. So they show, maybe they share their entire system, or maybe they share other sort of proprietary information or whatnot to be able to overcome that problem. But doing that kind of thing comes with a lot of trade-offs. Because that would come with risks of maybe sharing private information that you're not allowed to do for data protection reasons, or sort of that your customers or whatnot might not take kindly to. And then another issue that you might end up sharing information that you believe is sort of proprietary. And this is I think this kind of dynamic is a really, really big problem in this space. And often leads to difficulties of making sure that we have these verifiable claims about the various features of systems and of companies. However, there are ways in which these kinds of trade-offs can be overcome, in particular if the pressure to increase, to sort of be open, or to sort of or the skepticism of the claims that you are making as an actor are sufficiently sort of questioned. In particular, I think a really good example of this is Facebook's setting up the Facebook Oversight Board, where they basically gave up. In doing so, they actually gave up some of their power in making content moderation decisions. So it's actually the case that contractually speaking, the Facebook Oversight Board can make certain decisions about Facebook's content moderation, and Facebook actually does need to follow those recommendations. That's a pretty big move, I think, for any company to do. And I think one of the big reasons that happened was just because that Facebook faced so much criticism and so much skepticism from the outside world, and so they felt like the only way to sort of meet that kind of criticism was to make this fairly big move, or sort of to give up a reasonable amount of power over these kinds of decisions. Another way to sort of cut through these kinds of trade-offs is just via regulation, which often can just sort of mandate that certain information needs to be shared, or that there needs to be certain kinds of transparency into the organization or to the systems in question. So that's sort of the overall the sort of background to this kind of work, and so. What are the sort of main question that we ask in this paper, and sort of the main thing that we try to do is to then sort of lay out the landscape of what are tools that can overcome these challenges, and then we're trying to find tools that are that can be used today, but also tools that we believe can be sort of built upon today as well. So ones where so the community can sort of come in and sort of help build up these tools, and to make sure that we can use them to overcome these challenges. This is a list of sort of the ones that we cover in detail in the report. In the report, we also sort of cover a lot of other mechanisms that sort of fall into these buckets as well, if you want to get a sort of even more holistic picture. And so we divide them up into three different categories. One is sort of institutional. So this is looking at sort of institutional processes that could be used to increase, for example, organizational transparency, and sort of therefore be able to sort of have your claims about your systems be more trusted, for example. Another sort of set of mechanisms will try to bring in sort of more diverse sets, or sort of some outside perspective and sort of expertise into the process of sort of testing your systems, which might also be helpful. Another category is sort of software tools that can be used, or sort of things in sort of a broad category of software. I guess this is more about features of the actual AI systems. And then we also talk about some mechanisms to do with hardware. I've bolded here the ones that I'll go through in detail. I'll sort of talk through a little bit more next up. And they are third-party auditing, red team exercises, bias and safety bounties, interpretability, and compute support for academia. So third-party auditing. So yeah, this is when we try to make it the case that there is some third party, some actor outside of the developer, or who is not a part of sort of developing or deploying the relevant system. We bring in an outside party to sort of investigate the system and produce some kind of output, some kind of report, or whatever it might be, some kinds of statements about various features of the systems. This mechanism might be particularly helpful for a few reasons. One is that it sort of might help the developer be able to identify mistakes or sort of identify problems or issues with a model that the developer might miss. This might be because the auditor might have like a separate expertise that the developer might lack. It might also just be that they have sort of different incentives. So if you bring in an auditor, then at least compared to sort of cynically speaking, at least compared to the sort of the company or sort of the developer themselves, the auditor might be more incentivized to actually find issues or find ways in which the AI system might be causing or might risk causing harm. And that relates to sort of another reason that bringing in these auditors might be particularly helpful, which is that you might think that they have these incentives to that are sort of stronger than the developer themselves to both find issues with systems and also to, when they find issues, to not obfuscate them and to actually sort of report them accurately. And so if that's the case, and at the very least, if that's a thing that sort of other actors in this ecosystem is going to believe, then auditors are going to be pretty helpful because they can then make these claims that are more likely to be trusted as accurate by the rest of the community. And so this sort of dynamic might also make it the case that it's actually quite helpful for companies to use auditors or to use certification regimes or whatnot. Because if for example, if you're going to go to a regulator and say that your system works fine and works very well, then you're going to be that claim is going to be much more trusted if you can say that there was some outside expertise that also came to that conclusion rather than just your own team. These kinds of measures, these sort of auditing measures, can be sort of implemented in a whole bunch of ways. One is via sort of self-governance efforts. So companies might, for the kinds of reasons that I just laid out, maybe have incentives to put in place these things. There might also be incentives to try to get sort of certifications or sort of following risk management standards, for example, which might include the need to bring in outside auditors. And it might also be mandated in regulation. Is something that might happen. So similar things to this was suggested in this or proposed in this AI Accountability Act, for example, and perhaps we will see similar measures like this coming out in the US over the next few years. At the very least, we will see similar measures to this coming out of other jurisdictions such as the EU. There are some potential issues with this kind of mechanism that I think are important to figure out or to think about. One sort of mechanism that one sort of worry that I have in particular is sort of what you might call a risk of proceduralization or something. It's not a particularly it's not a term that rolls off the tongue. I'm sure there's some better way of putting it, but the sort of the thought is that over time you'll have this incentive to make it the case that the question of, is this system safe? Is this system not biased or something like this becomes sort of closer and closer to sort of a procedure that you can go through step by step. It becomes sort of a checklist that you can go through, where if you've gone through the checklist, then you've sort of fulfilled your responsibility of trying to figure out whether this system is going to cause any particular problems. You might have the incentive in this direction for a few different reasons. One is that sort of if I'm a developer, then I might be incentivized to go to an auditor that I think is more likely to give me a positive answer about my system. And then on the auditor's side, you because of that, you have some incentive to be able to say, it's a good system, it's okay. But on the other hand, you also have this big incentive where it would be very bad for business. Maybe you'll end up sort of having legal liability or something like this if you end up saying that a system is a-okay when it was not. And so therefore, the auditor might be incentivized to make it the case that their job doesn't look like do your very best to find ways in which the system might be causing harms and suggest ways to make it better, but rather to make their try to make their job closer to going through this checklist and making sure that none of those things are going wrong. I think this is sort of a potential risk that we're going to see in general in this sort of this space of responsible AI, or sort of trying to make sure that AI systems are not causing harm or have sort of various desirable features. And I think that might be a problem, in particular if we should expect sort of the impacts of AI systems to be sort of difficult to predict and a bit heterogeneous and whatnot. And so I think one paper, for example, that sort of puts this point fairly nicely is this thing that I linked at the bottom, predictability and surprise in generative models, where sort of the claim there is that when we have these in particular when we have these sort of very large models, it's often it often takes a long time and it takes a lot of work to actually understand what the system is capable of. And so maybe one of the sort of simpler examples might be sort of large language models, where it took a while and it took a lot of different people sort of interacting with the systems to start realizing things like that it turned out that some of these large language models had learned how to do programming, or at least do some rudimentary code and that kind of thing. And I think that if that's sort of if that's a feature that we're going to continue seeing in this space, then that might mean that this sort of proceduralization might be a particular problem. The next sort of tool that we talk about is red team exercises. So these can sort of partly be seen as sort of a response to these kinds of worries about this proceduralization, where in a red team exercise, you try to sort of bring in a diverse team of experts, and you give them the goal of just finding ways in which a proposal or a system is doing something wrong or needs to be updated in some kind of way. This might sort of deal with some of these above worries, because it sort of it incentivizes a slightly more sort of searching attitude. Instead of going through a list of sort of checks, what you're doing is you're doing whatever you can to try to figure out how you can break the system, and that might help you sort of identify new ways in which it might be causing harm, or whether there might be any risks or whatever it might be. A potential sort of worry with these kinds of systems or these kinds of mechanisms that I think one should be aware of is that they are quite often these red team exercises will be done sort of within a company or within a developer. That seems very good, and I think is something that if for example, if you all are involved in developing machine learning systems or AI systems for the use in healthcare, I would strongly recommend considering doing red team exercises like these. But one sort of, or I guess there are sort of two issues with that. One is that the claims that this sort of internal system or this sort of internal team makes to outsiders might be sort of difficult to be trusted, because you have this issue again where that sort of relies on the extent to which people will trust claims that sort of comes out of your own organization. And then the other thing is that sort of quite often it might be a little bit difficult to get the culture right, where you can sort of where an organization can handle having something like this happen. I think in particular with sort of organizations such as the ones that I'm imagining you all to be involved in, with our sort of more scientifically minded or whatnot, I think that could be you might be able to solve these kinds of problems. But I think for many organizations, these kinds of red team exercises can be quite difficult because it means that sort of you might end up in turf wars, or you might end up sort of someone's entire life project might end up being questioned or whatnot, and so that might cause some issues. And so sort of in light of those kinds of things, I think one thing that one should consider if one is thinking about having a sort of red team exercise done on one system is to try to consider having sort of outside actors come in and help out with it. And that might sort of help out with this sort of bringing in an outside perspective and outside expertise, and might also be helpful in sort of ensuring that sort of other actors might sort of see the sort of results that pop out of this red team exercises with a bit more trust. Another mechanism that I think is very interesting, and one that I would also encourage you all to sort of consider whether you could apply in your own projects, is sort of safety and bias bounties. So these are inspired by the sort of bug bounties that have been used in cryptography or crypto security, where you're basically, what you do is you give people, you sort of make a public statement where you say, if someone finds a bug or if someone finds a bias or some safety issue with my system, then and I can verify that that's the case, then, and maybe it fulfills these kinds of characteristics, then I will pay you some money. And this might be a very, very good way to sort of be able to bring in outside expertise and bring in sort of a wider coalition of folks who might be able to help find ways to improve your systems. Ideally, I think these kinds of systems would be, or these kinds of mechanisms would be sort of paired with sort of privacy preserving techniques of various kinds to make sure that you sort of see less of this privacy trade-off. I'll talk a little bit more about those later. And I think to some extent, these mechanisms could be put in place today, maybe not in a super complex way. Some very concrete things that one could do today would be, one thing would be if one is a company deploying some kind of selling a product to a bunch of users, you could just give the users a bounty for finding flaws in your system that you end up actually doing something about. Perhaps, you could give them a discount or something like this. Another thing that you could do is to just have some program where you give outsiders API access to your model, or some kind of limited access to your models that they can then use to try to sort of probe at it and see if there are any particular potential problems with it. Yeah, and I think sort of you might also you might want to sort of pair these kinds of things with what you might call sort of structured transparency techniques. So these are techniques where a sort of a broad term for techniques where you try to make it the case that you can sort of only share the one bit of information that you're interested in sharing. And so privacy preserving techniques is sort of one class of this. But there might be, you could do other ways of doing structured transparency as well. For example, you ask a very, very trusted auditor to come into your organization, and then on the condition that the only thing that they say at the end is sort of maybe a yes, no about whether a particular algorithm is going to, or a particular system is going to sort of fulfill certain criteria or not. But sort of making sure that they don't divulge any proprietary information other than that. Yeah, I linked this paper below that sort of goes through this concept of structured transparency that I think is really, really helpful, and I would recommend you having a look at. Another sort of technique, now we're moving on to sort of software mechanisms. Another mechanism that seems very, very important to push on is what you might call interpretability. So basically, I guess I use this term to mean anything that helps us basically understand how a system functions, why it sort of produces the outputs that it produces. This seems like a very important building block to basically sort of being able to verify any statement about any feature that an AI system has, because sort of in understanding how a system works, that might help you assess whether it has those kinds of features. It might also help you, in particular, it might help you figuring out how robust the system is, for example, because it might help you be able to actually generate adversarial examples, which you can then train your system on and therefore increase the robustness. Yeah, the sort of next sort of software technique that you might think about are these sort of privacy preserving machine learning techniques. And sort of the core intuition here is what I mentioned a little bit before, where a big problem is that you have these privacy trade-offs in these kinds of situations where there's a risk of leaking private or proprietary information if you sort of open up your systems to outside scrutiny. And if there are ways in which we could sort of reduce that trade-off, then that might really, really help us with being able to increase the extent to which we can build a trustworthy AI system. And so there's a bunch of techniques in this domain. Some examples include federated learning and differential privacy. And I think all of these techniques seem like they, in principle, if they end up working and if they end up not coming at too much of a cost to, for example, the to the performance of the system, then they could be, I think they could be very, very promising. One organization that I think seems to be doing some interesting and good work in this area that I would recommend you checking out if you want to learn more is this organization called Open Mind, which is doing a lot of interesting work in this area. Another sort of last recommendation or sort of last mechanism that we talk about is to provide compute power support for academia. And so the thought here is basically that we have a compute divide between industry and or a lot of developers and academia. And the thought might be if we sort of provide a compute subsidy to folks in academia, we might be able to make sure that academia can sort of retain higher quality or sort of retain a lot more talent and see a lot less sort of brain drain to private corporations. And it might sort of help them in the longer term be able to contribute to high compute research. And then the thought might be that this is going to be particularly helpful in building a trustworthy AI system, because you might think that sort of folks in academia are going to have more sort of public interest motivations, or they might have higher incentives, for example, to try to look for ways in which the system is not working well, or in other ways sort of make statements or make claims that might be harmful to a developer. And so this idea was pioneered by some of your colleagues at Stanford, at HI, who wrote this report on sort of a call for a national research cloud. Excitingly, that's turned into something that seems like it might happen. It's currently being there was a bill saying that the National Science Foundation was going to put together a sort of a task force that would explore this idea. They've done a bunch of exploration, put out an interim report recently, and I guess we'll see where it goes from there. I've done some work on these questions myself. Which looked specifically at basically we specifically recommended that in addition to this sort of national AI resource, in addition to it sort of providing folks with compute, we argued that they should also make sure that this sort of resource could also provide folks with access to pre-trained models. So instead of, if sort of one of the main things that we care about is we care about giving academics access to high compute models that might be difficult to train yourself, then maybe a sort of a way to short circuit that system, or sort of to help that goal in another way might just be to make sure that you get access to those models. And so the concrete suggestion is to make sure that the National AI Research resource sets up basically an API where academics, for example, could give access to their models. Other companies that want to sort of give broader access to their models, they could put them up there, and those models could then be sort of given out to those researchers who we can be sure are sort of doing something useful or doing something pro-social with that model, or sort of probing it in different ways, which might be helpful to society as a whole. So yeah, those are some of the recommendations, or some of the sort of mechanisms that we talk about. There's a whole bunch more to work on and to consider. I think just to sum up, I'll sort of summarize by saying that to build this sort of trustworthy AI ecosystem, we need to sort of help society gain a calibrated level of trust in developers and in sort of specific AI systems and in this technology. To do so, we need to be able to verify claims about AI systems and about their developers. And we also need to make sure to be able to communicate those claims to other actors. Having done so, the wider community could then be able to offer appropriate rewards and sanctions to AI developers and help us build this sort of more and more trustworthy AI system over time. There are lots of mechanisms that we could pursue here. And my guess is that sort of the ones that I highlighted here, if you are involved with sort of actually developing AI systems that are going to be deployed in the real world, I would recommend you consider using all of them, other than, I guess, the last one, which is more of a sort of high-level recommendation. It sort of pertains to another part of the ecosystem. And I would love to hear more about what your thoughts are on all these mechanisms and yeah, learn more from you. Thank you all very much.